any action as the user running the browser. In many cases, unfortunately, especially a home user is running with administrator privileges, so the attacker can take complete control of the system in this case. Crossing the domains, or crossing the zones, is really the key to the whole realm of attacks that we've seen. There are a lot of features and things that may or may not be a vulnerability that allow certain behavior to happen, and they're fine when they are restricted and kept out of the local machine zone or restricted in their zones or their domains. When you can cross a zone or a domain, that's when the problems really start. And an interesting combination, as I'll show, of what we would say is a vulnerability and features in Internet Explorer. So there's a sample URL here. I hope it is readable to some of you. And I'm going to illustrate this as we roll through here. Sorry, very last piece at the bottom there, to keep us up to date with the history. HTTP URL moniker, just to illustrate again, these URL monikers keep cropping up with problems. I want to investigate this URL a little bit further to demonstrate what an attack looks like. So again, I hope some of you at least can see the red here. This is an interesting URL that wraps 3 protocol handlers and 3 references together. And it's fairly confusing and complex, and that apparently led Internet Explorer to not properly judge what zone different references, different files were referenced in. First, compiled help uses something called the info text storage format. It's simply a format to encode different elements in a single file. Internet Explorer has a set of protocol handlers that can read into an info text storage file, which is almost certainly always a compiled help file. 1, 2, 3, 4 protocol handlers. And that last one, the mk@, msitstore, is included for Internet Explorer 3.0 backwards compatibility. These protocol handlers can read into a compiled help file and pick out a certain element within there. It's not a vulnerability. It's certainly useful to read into the compiled help files. Remote help files, maybe that's questionable. Next up, the next layer in is the line encapsulation of aggregate HTML. MHTML from now on. So MHTML bundles HTML elements. It could be some images, plugin, ActiveX control, plain HTML script, all together in one file for easy transportation, for instance. And the MHTML protocol handler reads into this file and can read out bits and pieces. Again, not really a vulnerability. It's working by design. It's nice to be able to read into those files, certainly. So the MHTML part of this URL is MHTML:, and then the MHTML file referenced in this case is nofile.mhtml. Where this starts to get interesting is if the MHTML protocol handler cannot read the file that's referenced, and in this example, nofile.mhtml is something that just doesn't exist. It will look at an alternate location specified by the exclamation point, in which in this case is a remote file on a potentially malicious site. The third layer in of this onion is the file protocol. And again, not a vulnerability. IE and lots of other browsers use file : to read files off the local file system. Just for the point of the example here, file : is referencing the C drive, and then next is the file.mhtml. So, as I mentioned, when MHTML can't access the first file because it's not there, it goes to the alternate location, which happens to be on a remote site in this case, and it does not, at that point, check that the zone or the domain is switched. So, the MHTML, instead of operating on a local file, which would be in the local machine zone, which would be acceptable, is treating the remote file on HTTP attacker.com as if it were in the local machine zone, running script in there, and it's a cross-domain vulnerability, and it's off to the races. So again, the point with the cross-domain vulnerabilities, these are really the key to almost all of the recent attacks and all the most serious vulnerabilities that involve the IE technologies. There are lots of technologies that might be called features or are design behavior, which provide a wonderful user experience, provide interoperability, provide ease of use, and if they are well separated into the zones and the domains, there are no problems. The issues are there are many, many ways that a reference might be made across frames, across windows, across domains, across zones, and without a way to carefully check every single one of these references, there are going to be mistakes. We're going to miss some of them, and attackers have been looking for these. Attackers and researchers have been looking for these ways to cross zones, and they've been finding them for years now. Attackers are reusing code. This is fairly interesting. There are chunks of script, usually JavaScript or VB script, that deliver the payload. And these chunks of script will go to a remote website, download, overwrite a file, and run the file. They will get the arbitrary attacker's executable on the system and maybe run it. Sometimes they contain the attacker's executable in an ASCII format, in an array variable within the actual script, and they will unpack that and write it out to the disk and then execute it. So if that script is sitting on a website in the internet zone and there are no vulnerabilities at the time, clicking on that URL is harmless. The script will not run properly. It will not be allowed to write the file to the local system and execute it. In the presence of a cross-domain vulnerability, that script is put into the local security context, and then it is executed, and it can then take these malicious actions on the system. So there's these relatively easy to recognize bodies of code out there, and for the past 3 or 4 cross-domain vulnerabilities, attackers have just plugged in the next cross-domain vulnerability and reused the same code to go out and download the malware and install it. Talking about the spoofing a little bit more, a lot of the control over the user interface features built into IE, which make it very powerful and programmable, can also be used by attackers to open windows off screen, minimize windows, hide the status bar, hide the address bar, cover dialog boxes with other things, completely spoof the entire screen so that the entire screen is in control of the attacker. We already have people opening archived, password-protected attachments and running what's inside. If the entire screen can be spoofed, the attack's going to succeed in almost every case. What's a little more alarming is what we haven't seen. A lot of the attacks we've seen involve spyware and adware, and even though we don't like them, spam bots, denial of service bots are certainly dangerous things. What's more concerning is there may be attacks going on that install a good backdoor that gives an attacker repeated access to the system, a long, slow attack, a directed attack against a sensitive site, against government military sites. These things are not reported publicly for obvious reasons, but if there are more dangerous attacks going on, that's below the radar of all of the spam and spyware and adware that we're seeing. In the case of a cross-domain attack, especially with administrative privileges, the attacker can distribute anything they want. It can be as relatively benign as spyware or adware. It can be a proxy that allows spam to go through the machine. It can be any virus, any backdoor, any Trojan horse, denial of service agent, remote control agent, absolutely anything the attacker wants to deliver. We always recommend updated antivirus signatures and an updated antivirus product. A lot of antivirus vendors are checking for spyware and adware. A lot of them are checking for this commonly reused attacker code. A lot of them have maybe an HTTP proxy or an HTTP inspection engine that watches stuff coming in from the web to look for the commonly known attack code. The problem, of course, is with all signature-based detection is that it's signature-based, and if an attacker can slightly modify something or mildly encrypt the whole thing with the VB script array, you're probably going to beat the inspection engine. And the slightest changes can beat the inspection engine, and any new attack code will beat the inspection engine as well. HTTP content filtering, again, that's covered in what I just described. It's possible to watch HTTP traffic coming in